Welcome back. Today we're doing a build. So we're taking this toolhead and rebuilding with the new printed part. So this is a Clickchanger with Rapido hot end. And why we're rebuilding this one is that this switch here broke. Hello, focus. So it was pretty much destroyed. And so the new printed part has a fix, so the switch is more recessed into the part. And I haven't really figured out why exactly this thing gets hit, but this is my third switch that this is destroyed. I had to order more switches, but for now I just made a quick replacement. And we're going to take this apart and rebuild from scratch using these printed parts. Alright, so let's get started. Oh yeah, before that, so the other things you're going to use, so there's two new bushings, a pin, a few heatset inserts, a few magnets, some super glue, and yeah, a few parts we're going to salvage from this one. So yeah, as you can see, this is a very kind of the simplest design that you have, with just a stock orbiter extruder, stock Rapido hot end. Then I'm running mellow fly toolboard, and yeah, just a single fan. So okay, let's take it all apart. And yeah, we're going to obviously use all the screws, and I'll later salvage all the other parts, but for this build we're just going to use all fresh. Yeah, I need another one. So just a quick tear down so we have everything we need. Come on. Okay, there goes our not giving in. Hello, I want you disconnected. It's super tight fit. Okay, I'll just leave it out. Just one wire came out. Oh well. Alright, so we're going to use the TFT tube, and now the hot end. Yeah, I'm just doing a quick and dirty disassembly job. So this one, now we need to take apart the back one, and we can remove the clips retaining all the wires, and this one will not come out. I think it's a bit super glued in place. The good thing is that we have a replacement, and now we're going to do some destructive disassembly. Come on, you can do it. Yes, that sounds about right. And right, there you go, there you go, there you go. All right, so this is the old part. Oh, I need a screw. That will be disassembled later. For now, let's just put it aside and observe the damage. So I want to disassemble this a bit, just to make working on it easier. And I would really like to disconnect the motor. Let's see if we can pull it off. Come out. Yes. So this is just the cradle for the toolboard. And now, hello. It's clicking back on. Oh yeah, there. All right. can we fix this? Hope so. The pin that's locking it in is kind of bent. Let's see if we can fix it without destroying it. And without destroying any fingers in the process, please. And not yielding at all. I really don't want to re-crimp you. Please work. Come on. In worst case, I probably can jam it in as it is. But that will just take time until it's out again. No, it's not working at all. Oh well, for the sake of this build, I'll just jam it in and hope for the best. Okay, let's take a look at all the parts. So, extruder, check. Toolboard, check. Let me put this back in so we have less of a mess. Yes, there. Okay. And yeah, I'm going to keep that as is. Fan, check. Switch, check. Super glue it out of the frame. The old switch is still functional, I think. Hello, focus. No, it's bent. Yeah, that is garbage. Okay, that goes away. So what else can we reuse? This one is quite destroyed. All right, so we need to take this apart as well. Missing one screw for the hot end. Yep, check. Clips, check, but we have new ones. Let's get rid of them. All right, taking this apart. What approach will it take? So this is super glued in place with like a tiny dip of super glue. I think I'll just cut it open. Nice. Okay, don't break, don't break. Good. Yeah, some of the insulation stripped, but otherwise. There. That looks pretty good. Now repeat on the other one. Okay. So yeah, as I said, this is the more tricky part of this whole construction. And there is a CPAP version coming up where you don't need this. And in general, you can probably just run some wires. All right, that worked out as well. Let's take a look. These guys look in a reasonably good shape. That still works. That works. Nice. All right, so I think we have all the parts. And I have a test shuttle, obviously without the fan. Actually, I do have one with a fan as well, but this is the older design with the bigger slot for the switch, and that's what we're changing. And this one has half of the size of the slot, so it's sticking out less, should be less prone to destroying itself. Alright, and now just need to unwrap the new parts. And yeah, as most of my designs, these need some support. Oops, that fell on the floor. I really cannot be bothered designing supportless or built-in supports. ABS is really nice, and ASA for finger removable supports with minimal tool help, so I don't see the point. If you do like PLA, PETG, yes, supports suck. For ABS, even without extra like special solvable or like just running a different filament for supports, it's fine. Yeah, 90% of things, 90% is a finger removable, minimal tool use for anything else. Okay, so we have some supports for the holes where the pogo pins go. Okay, good enough. So one thing I want to clean up is this side, because that's where it's going to sit flush. Yeah, good enough. And now the big one. So I had a bit of a bed adhesion mess. It's not perfect, but good enough. Yeah, this is what I'm not really happy with the Revo piezo. It's too sensitive. I'm running it, so it has like 2 different modes and like 4 sensitivity levels in each mode. So there's like a filtered mode that is like quite robust for like accidental triggers, like on any background things. And then there is filter off, which is super trigger prone. And then the other setting is what's the sensitivity threshold. And I'm running with filter on and kind of quite low threshold. And sometimes it over triggers in thin air. Sometimes it doesn't trigger at all and just runs into the bed. So very much aiming for not running into the bed, and maybe sometimes just needing to restart the cancel print, but still the bed distance results are not perfect, so this is slightly too high. You can program it via UART, but yeah, haven't gotten around for that. So yeah, just removing the supports here, and with just a bit of cleanup, this should be good to go. Hello. And there is a trusty deburring move. Yeah, one more thing, all my parts are designed to be printed slightly undersized. So what I'm using is just external parameters first. That gives you like very good accuracy, but it does result in like sloping areas like this, sometimes getting outer layer detached. It's usually just cosmetic. So I'm been mostly fine with that. You can probably get away with slightly oversized parts, but this is not what my designs are for. They're for spot on or slightly undersized. So yeah, just deburring all the important parts, but there's not much to remove because it was already slightly too high, so the skirt is not really, it's removing really nicely, not sticking at all. Okay, let's get rid of all the mess. Okay, so here's the plan. We need to install heatset inserts, install the bushings, install the pin. Once that's done, we'll install all the main parts, the hot end, the extruder, the fan. And lastly, we're going to install the magnets. Or why not? We can start with the magnets. So one more thing is that this project does need quite a bit of, not quite a bit, but it does need super glue. So, and let's make sure that the orientation is right. So I'm just going to use the previous magnet's orientation and transfer it over. Hello, please go in. Yes. And depending on what magnets you get, like these are designed for 3mm magnets, but these guys were sold as 3mm and they're more like 2.6, so they're slightly recessed. And all the places that need super glue have like a small gap. This one is right here, where you can just squirt a bit of super glue in, and it should distribute itself nicely. Hello? Anything in here? Like this is a new pack. Should be something in here. Hello? Still nothing. I'm hearing some sounds, but no glue. That would suck. Okay, no luck. Let's try the next one. That's not what I expected. Okay, please have some glue. Seriously? No glue? Oh, something's coming out. Oh shoot, this is the super thick stuff. No, this is not going to work. Like, yeah, it's all this like gel stuff. Like this needs like a fairly free-flowing super glue. Let's go with the big buy. Like, I just wanted to show with the small one because it has the tips that's very nicely sized for this hole. And this is going to be somewhat awkward. Yeah, it's going to overflow. Not great. So yeah, TLDR, get yourself some of the easy flowing liquid, not the viscose gel stuff. Now I want to clean it off with something. No wipes, no wipes, no wipes. Oh well, finger is always an option. Okay, there, we have the magnets installed. Let's just, okay, I don't want to rip them out just yet. Let's leave some time for the glue to set. All right, let's move on to the heatset inserts. Yes. I need the right temperature. I just use this to do the soldering job for the switch. Okay. And the heatset design here is not super great. It's serviceable. So there's like, from this side there are grooves for the dock. And this heatset insert almost interferes with that. Also, ideally I would like to insert from the other side to avoid any potential rip outs. There's like 10-ish kilograms of force that's applied by the extruder. All right, in you go. So looks good. So that's taken care of. All right, yeah. Once we're done, I have a prototype, gazillion supports, prototype rigid dock. So we're going to try this out with this once we're done. And yeah, I'm still figuring out what to do with all the supports. So this is PTG, and with ABS it's not a problem. With PTG it will be a bit of cleanup to do. Right, next inserting the bushings. So these are just finger tight, and this one is a bit more tight. So the bushing slots are a bit special. They are finger tight vertically, but horizontally there is a bit of wiggle room back and forth. And the goal is that I tried making them like really tight so you can just press them in, but the printing tolerances are not there. And what happens is that you always get like a 50-50 chance of them going in nicely and or them just being super, oh shoot, one of the magnets came out. Alright, I'll use the opportunity to put some super glue at the bottom. Normally you don't need to do that if you have like nice flowing super glue. So yeah, what I was saying is that, oh shoot, a lot of super glue going everywhere. Okay, back in business. What I was saying is that, yeah, the printing tolerances are not perfect, and I ended up having to throw away every other print because the pins will just not go in, or will be like super resistive. What's the right word? And this way you kind of put in the pins once that makes the bushings wiggle around, find the right place. So now we need to insert the pin. This is a bit more involved. Oh, I haven't cleaned up all the support debris. Hello? There's just a tiny bit of support left. Come on. Yes. So there's like a slide. So all the pins are pressed in. So you just put this one here. There's like a slight groove for it, and you just go and compress, and it will align with the hole and click, go in there. And now I need to clean up this side a tiny bit because it ejected a bit of wall material. So yeah, there's no glue going into the pins, they're just, oh, this doesn't work, it's just press fit. Yep, there. Okay, now we can test the fit. Okay, that's a nice satisfying click. And now we can glue in the bushings. So there's like a hole right here, and there is a groove around the bushing. So what happens is that super glue just goes in and fixes the bushing in the right place. And yeah, this will do, but it's not the flowiest super glue. Yeah, that's something I need to put in the bomb. Get yourself a thin super glue. This says flowing. This is German, flüssig. So that's like. Okay, will be good enough. Like normally the super glue just flows in, but now it's semi sitting down there. Okay, let's get rid of you. And yeah, one thing I forgot to remove from the last one. So there is a screw hole here for the retaining screw. Let me quickly remove it from here. Okay. And this is where the name comes from. So it's Clickchanger, like, because it's doing a nice clicky sound once this one is in. Okay. All the way in is usually too far. You want to back it out a bit. And super glue in place. So this is too tight. I don't feel any resistance. Still no resistance. Yeah, so what's happening is that this bearing will press against this screw head, and that will cause it to, okay, yeah, now, there, that's what you want. So you want it to not close it by itself by the magnet's force. You want to have a bit of a click, and it really removes all the slop from the system. It makes it slightly more forced to remove. Let me show you a thing. So if I screw it right now all the way in, so there's no resistance at all. So this thing, okay, in this build it actually is pretty tight. But depending how center your bushings are, you will get like a bit of a wobble around without the click. Let's go back. And okay, that's too much. Yeah, so there. And this also like makes it more difficult for the whole thing to accidentally jump out of the shuttle once it's mounted. And what I'm aiming for is roughly 1 kilogram of lift-off force. So if you like dock it and then you want to remove it, it's like 1 kilogram. This is maybe slightly more. I should actually, yeah, there. Okay, so that's the basic thing in place. So the shuttle goes away for now. And we continue with the installation. So I will, oh, super glue doesn't leave me alone. We will start with the hot end. So this is a bit of an old and seen a lot of things hot end. One of the things that it has is removed there's like a metal plate that holds all the wires so that you don't accidentally yank them out. So this one is removed like a while ago for another thing. What it makes easier for me is to kind of put all the wires here because they're more compliant. But yeah, you might need to bend that metal plate so the wires come in nicely. And also the holes are angled a bit to make sure that the wires are close to the hot end and not, yeah, close to the body of the thing, not dangling around. All right, let's bolt it down. Did that hit? Yeah, that's good. Oh, wrong one. Small ones go here. That's for the extruder. Okay. Oh no, you nasty one. Go back in. And you just want to tighten them as normal. And so what's happening now is that as I'm tightening, the hot end is also pressing on this part here. It's probably not visible, it's just there's like a slight lip down there that's making contact with the heatsink. And let's just verify that we're still reasonably aligned. Oh yeah, but as you see there's no more click, and that's why, the reason is why that this whole thing got a bit shifted around, and there should be now a bit of a tension going into that piece of plastic. So let's tighten it again. Yeah, click is back. Okay, so the other side we have the fan, and it's like a super simple install. Just put it in place, 2 and 3 screws in. I have thought about making the fan install screwless, just kind of design a housing where you click it in, but haven't found a good way to do that. It's just a lot of very thin walls around it, and just having 2 screws is probably more weight, but more easy to do. Okay, so that's that. Next one would be, oh yeah, if you're wondering why I have these holes here, these are just for hammering out the magnets in case I want to reuse them. So once they're super glued in, they're not coming out easily, so I can just hit them from back. Okay, let's just add this one while I remember it. Okay, so next one is we need to finish the retaining clip for everything, and we need to get the pogo pins in. So there's like tiny sign, this is minus, this is plus, and accordingly this goes, oh, this is really hard to show. Okay, so it should just kind of press down, finger tight or nail tight. Can't get there with fingers. Just using my nail to press it down. Okay, and let me, oh no, that's not going in. So let me just use a hex tip to press it in. Okay, that's all the way in. So what you want to have is like a millimeter sticking out the other way. So you kind of, like the left, hello focus. So the left one is maybe sticking out a tiny bit too much. Oh Jesus, not focusing at all. Right one is about right. What can I do to make you focus? So yeah, I'm just going to push the left one a tiny bit back with tweezers. Good. Okay, and now to fix it all in place, Good old super glue. So verifying minus, black to minus, red to plus. And probably last time for these guys, they look a bit pretty beat up. I suspect next time the wires will just snap, and I'm going to try to disassemble. And now we have a dilemma, because I need to use this part, but it's dripping with super glue. I don't want more super glue that I already have on my fingers. So let's put that aside and try to install the hot end. No, extruder. What am I talking about? No, better not. It's going to make installing the rest of the things here really hard. Okay. Let's put that aside. So for the prep, so what's happening here is that the switch will go in here. So there's just like two printed pins that go into the holes. Like that. So it's still sticking out a bit, but way less than before. So like half the size. The hope is that it's going to be helping. And now let's install this one. So this is the semi-finicky part. So what you want to do is get it here and then push down in these grooves. Okay, need to get orientation just right. Yep, there it goes. And then you press it inwards to close it in. And it should be containing the switch nicely from both sides. And to finally lock it in, there's two tiny clips that are super prone to breaking. No, probably worth designing a bit more beefy ones, but I just print new ones every time. I need a bit more removal. I see there's more of this brim remaining. And the two clips go down, and that's it. So while we are here and the extruder is not installed yet, we can finish the put back the toolhead. Oh shoot, that's not good. I think I just, yeah, that's a cold solder joint if I have ever seen one. Okay. We have time, right? Let's fix it. So, not going to disassemble it all the way. We have enough leverage here. Let's get some helping hands. Let me zoom in. This is going to be a tricky one. All right. So, and I need some shrink tubing. Give me a second, we'll be right back. Okay, we have a matching yellow shrink tube. And come on, off on you go. Jeez. Whoever did this solder joint really made a mess. I think I know who it was. Yours truly. Okay. Now we need the Yes, good. We have power. And we need 350 degrees. And a bit of flux. Okay. And a bit of, sorry for the noise, but I don't want to breathe the flames. Okay. It's still heating up. Oh. No? Hello? Heat up, please? Yes. All right. How does it look like? Oh, holding up. Okay, good. That was a quick detour. And heat shrink. On you go. Nice. And a bit of there. Good as new. All right. Let's remove all the mess. Get back to what we were doing. All right. So where were we? Assembling the thing. Okay, so these all things go back into our slot. And the retainer goes in here. Okay, nice. We're back where we were. Nice. And super glue has dried. Double nice. Okay, let's close this up. So my fan goes, this is going to be really tricky to show. My fan goes here. My other fan goes here. Oh yeah, quick description of what this toolboard is. So this is Mellowfly Pro, which is a very limited thing that doesn't even have English documentation. It's only Chinese. I did pick it up because it has 5160, like the more fancier stepper controller that has less heating. And this, yeah, just a fun thing to play with. And it also has like selectable voltages for the fans, so some nice things. All right, and now for the detection switch. So that one I'm using the like leftmost pins right here, and I don't have the proper connector. I'm just jamming in a general 0.1 inch thing. Okay, I have everything except the extruder. Now we can click it in place. Okay. And this is going to require a bit of, you want this to be tight, you don't want this to get loose. Nice. Yeah, this is printed in ABS. It's very thin walls, so preferably if you can print it in PETG, just for better wall adhesion, or you can just coat it with one coat of acetone to get the wall adhesion up. That works really well as well. Okay, so let me kind of roughly arrange the wiring here. So here's the deal with the switch position. So right now it's sticking out, like ideally it should be like flush and then I don't have concerns of it getting destroyed. But now it's sitting like 2 millimeters down. On the other side we have the connections for it and they are sitting about flush. And what I did there is, let me show a destroyed one. I actually trimmed down the terminals really short. Hello, focus. So they're like 2 millimeters long, pretty much. Just to minimize the interference with the motor. Because what's going to happen is that now I'm installing the extruder. The motor is sitting on top of that switch. And you don't want them to make contact. Trust me. Okay, so this is all good. Now we can, before putting the extruder in, we need to plug it in and we need to deal with that black wire having a problem. Okay, hello. I don't need you, go away. And clicks. And yeah, that black wire obviously jumped out because it's not fully retained. Oops. So I'm just using whatever I have on hand to push it back in. And I'll need to revisit whenever I rebuild this. Yeah, seems to be holding in for now. Okay, now you come down on your tube. There. Nice. And let's put the screws back in. Great. Just lost that screw in. There. Good. And that's it. We're done. At least with the hot end part. No, extruder part. Hot end extruder and toolboard. No, toolhead. That's the word I'm looking for. Okay. So just cleaning up a few things. So let's check again. Oh yeah, let's fold you away. Yeah, this is something probably I can improve to make the shroud a bit more closing in. Like, it's a bit of conflicting requirements. From one side you want the motor to be exposed for cooling. From the other side you want all the wires to be covered up. So it's roughly self-contained, but it's still exposed. Okay, so test on the clicky thing. Nice. And nice. Okay, cool. So that's done. Now this one, the dock. So I have spent quite a bit of time optimizing the dock for the integrated gears. For this one, the dock is super simple. There is just kind of 2 grooves here, one on each side, and there is M3 screws that sit in there. Let me show you what I mean, and let's see how easy it is to remove the supports. Oh, surprisingly easy. So this is super stringy because I didn't bother to dry out the filament, and it's winter outside, so everything gets wet and stringy. I'm especially annoyed with flexibles. My TPU, it's for PTG, you can live with it if you don't really want to have super smooth parts. For flexibles, it's just oozing like hell, because you need to print slow and you cannot do much about it except dry it before every use. Like normally you need like only half a meter of a flexible, then all the part that exits the dry box gets wet, and next time you use the wet part. Okay, this is turning out better than I expected. It's a bit ugly, but at least it's removed. The removal goes well. Yeah, there's like random crap in here. Oh, it's black on black, great. Generally didn't need the brim, but I was just afraid that this is like a vertical and skinny part that it will make a spaghetti. But normally PTG works well without the brim. Getting it out of the build plate is the problem, especially for small parts. Okay, I'm not going to do the rest of the cleanup. There's a lot of like small yank here. Okay, I actually do not have the clip to hold on the nozzle wipe, so let's pretend that I have it, or not. So here's what's next. So this thing goes in here. No, it doesn't, because there's too much junk. I'll need to do this after all. So yeah, word of advice, use ABS for this part, or just use the lift bar and then the part is way simpler. Maybe I can split it into kind of this way and then you screw it together, maybe. Okay, it should go in now. So yeah, this is where it's sitting. It's supposed to sit. No. Yes, that's correct. And the only thing that we're missing now, we need to install two M3 bolts through here. Where are my bolts? Screws, screws, screws. Will this size work? Yeah, that's about the right size. We want both of them to have this smooth section. Okay, I have two that work, but one is just like all thread. And I would prefer a smooth section. Okay, not exactly the same look, but close enough. Okay, now is the boring part of getting them in, and this is the first time I'm trying to do this in PTG, and no, this sucks. I need a bigger driver. And you scroll them all the way until they rest on the, whatever you would call this, pad, piece of plastic. So the function of this one is really to kind of give you a rough idea how long it is supposed to be, and maybe remove some flex from the screws. So actually you need to be careful when screwing this in like fast, because the screws will heat up and you can melt that thing, especially PTG, and then you're not going to get them out ever again. Good. Okay, that's that, and let's test if it works. Yes. And yeah, here's another limitation of the dock. So it does hit the fan. So this is a problem with all the designs, that the fan is in the way, And I just need to be careful with like the toolpath. Like there's 2-3 millimeters of movement here, so plenty of practical movement. I could potentially change the dock to grab like somewhere on the top, but then it makes it tricky with like all kinds of extruders. Having it grab from the bottom is nice, that like you can mount pretty much anything on the top. So it grips surprisingly well for just being 2 and 3 toolheads, bolt heads. Toolhead bolt heads. Okay. I think that's pretty much it for today. So yeah, let's maybe try to simulate like a full tool change the best I can do with it being horizontal. So yeah, here's your, okay, let's actually do this. Here's an actual shuttle from the rail. So this thing comes in. I'm thinking if I can, yeah, let me do this. So let me bastardize this out of date thing. Yeah, so this is quickly how the shuttle works. So there's 2 wires going to each of, 1 wire going to each of the pins, and there's like a small hole here, and then it just kind of goes all the way up top, and then it's just jammed between the pin and the plastic. And here's a fan, and there's like 2 grooves at the bottom to attach it. You can always add super glue to make it permanent. I'm not going to do it because this one is going to get CPAP. Yeah, okay. So here's what's coming in. Oops. There. And then it's coming from down here, lifting it all up and lifting it away. And yeah, so you did see that it didn't engage fully, so you need to push it up a bit more, and either the weight of the toolhead just pushes it down, or if it doesn't, what eventually happens is that the fan hits this piece of the dock and that pushes it down. And then away we go, and coming back in down here. So now we need to pull down, get it disconnected, and away it goes. And yeah, so what's missing here is the nozzle pad. That gets installed in this black on black groove, and there's like a small clip that secures it in place. So for mounting this dock, oh, let me remove some bits. Like these slots are just so that you can align neighboring docks to be like perfectly aligned together. So for mounting this, so here you can mount it to the top extrusion with like a 8mm M5 screw and T-nut. And here, like this is optional, you can just mount it on the top. It will be a bit flimsy, up to you, like depends. Like I found it a bit flimsy, so I'm mounting it a separate extrusion at the bottom. By default, it will interfere with your idlers. So I'm using low profile idlers that don't interfere with an extrusion mounted inside the frame. Alternatively, you can have an extrusion that's kind of sitting outside here, but then you need to redo the doors and the rest. So low profile idlers and extrusion here is probably my recommendation if you want to go with a static dock. And yeah, that's pretty much it. So we redid it to head, and next time I'll try to do integrated gears tool head. That's a bit more complicated process and looks like this. And in comparison, this one is lighter, and the tool, like the filament path, is about 9, maybe a bit more millimeters shorter. And one more nice thing is that it has, like, you can just use your finger to manually extrude if you need to, and I find this like super useful when like loading filament. Otherwise they're pretty much identical. So I have, no, this is an old one, sorry. This is the new one. So I have two heads with the new placement of the switch. And the next step is to go and replace the shuttle. And essentially all the old tool heads are now non-functional because the switch will be definitely destroying. Like this will definitely be hitting the switch. So I'll be printing with two for a while and redoing the rest. But yeah, first let's test this with two, see if I get the repeat hits, repeat destruction of the switch. And if all goes well, then this is going to be the 1.0. Cool, all right, thank you all for watching, and happy printing. Cheers.